Alright, so it's time for us to understand how to read the values. Alright, back to this same resistance now. 103. What does that mean? How does that tell us the resistance? It's very simple. You first of all take out of these three digits, these first two, the 1 and 0, you write it down somewhere. This first two is this first two, 1 and 0, you write it down somewhere, then multiply it by this last one here. But now this is the first digit. This is the first digit. Alright. So this is the first digit. The 1 is the first digit. The 0 is the second digit. And this third number here, this last number here is the multiplier, which means 10 raised to power 3. Now, for the reading of this resistor, it is 10 times 10 raised to power 3. So that means 10,000 ohms, which means 10 kilo ohms. So this is a 10 kilo ohms potentiometer or variable resistor, depending on the application. Alright, so what that means is, if you read the values between here and here, between these two pins, you will get 10 kilo ohms. And if you read the value between here and any of these two, for example, between here and this, between these two pins, you will get any value between 0 to 10,000 ohms. 0 to 10 kilo ohms. If you also do the same thing here, if you read the values between here and here, you can get any value between 0 to 10 kilo ohms as you are turning as you are turning the resistor, because this is where you turn it from. So let me show you an example of turning. This is how you can turn. It's very, very simple. Alright, so the next step now is let's do the same thing. Let's look at another resistor. Alright, let's measure this resistor to be very sure of what we're saying. So we're going to take our multimeter again. I'll put it in. I already know that this is about 10 kilo ohms. So I need to put it somewhere that can accommodate 10 kilo ohms. So I put it on 20k, because I know that can accommodate 10 kilo ohms. So the next thing I do is take these two pins, one of them, put this here, and then do this. That's 9.4 kilo ohms. Every resistor has its own tolerance value. So this one, the fact that it is 9.4k does not mean it is wrong. It just means that is the current resistance value based on the environment, the parameters of the environment, such as temperature and whatever. So now let's measure the resistance between two of the probes. And to do that, I'd like to show you how to do it using it in a very good way. So I'm going to put this in a breadboard. Put it on a breadboard, and then so that it will have to be stable. And then I take, put here and here, you get 4.9 ohms, 4.9 kilo ohms, and between the other side, I get 5 kilo ohms. This is so because if you look very closely, this this thing is actually like is at the center of the two, is in between. The wiper is currently in between the two ends of the fixed resistor. So let's vary it and see what will happen. Alright, so now I'm going to vary it. As you can see, the resistance is changing. I'm varying it towards one side and it's reducing, and now it's 0. Now let me take it to the extreme while leaving it can go up to 9.4. So that is a variable resistor for you. That's how it is. And let's read and now take another example. This is a 503 variable resistor. If you get to see that soon. So this is a 503 variable resistor. I'm waiting for my camera to adjust. Alright, 503. What that means is 50 times 10 raised to power 3, and that is 50,000 ohms. Another one here, 204, which means 20 times 10 raised to power 4, that's 200 times 10 raised to power 4. Sorry, 20 times 10 raised to power 4, that is 200. Sorry, 20 times 10 raised to power 4 is what? That was 200,000. That's 200 kilo ohms. That is what this means, 200 kilo ohms. And it's very easy to use. They all work the same way. So that's for variable resistors.